monosaccharide by a glycosidic bond. The bond to that anomeric carbon. But it's not just toxic things that are attached there. This glycosidic bond can be used to attach one sugar to another sugar. And that's how you make a disaccharide, or trisaccharide, or starch. So here's alpha amylose, one of the components of starch, amylopectin, also in starch. These colored linkages there link the anomeric carbon to another hydroxyl. Well, in this case, it's not making an amygdalin or some nasty thing. It's just making a link to another sugar to the hydroxyl at the number 4. This is a glycosidic bond, another glycosidic bond. So glycosidic bonds are the way of snapping together monomer sugars to make polymer bonds, or to make a disaccharide like sucrose. Two sugars linked together through a glycosidic bond. And remember, we talked about this as the polymer strategy of making macromolecules. So all you need is an enzyme that will build a glycosidic bond, and you can assemble huge molecules that way. So it's again between the hemiacetal carbon, the so-called anomeric carbon of one sugar. Like in the ring, if this is the edge of the ring, that's the alpha form, alpha hydroxy form of some sugar. You take another sugar with its hydroxyl group and you attach it on there. And as you make this glycosidic bond, it's a condensation reaction. You are removing the elements of water. You'll remove the hydrogen atom and the hydroxyl group, and that will link directly to the next sugar. So it's a condensation reaction that eliminates water. Of course, that makes the reverse reaction when you break down a starch or complex carbohydrate of any sort. Breaking that glycosidic bond is a hydrolysis reaction. You're adding water across the bond to regenerate the component parts. And for ketose sugars, it's the same kind of deal. Okay, so when you start building up longer things, disaccharides and trisaccharides, there's a naming convention.